Hello everyone, welcome to the Martin School. I'm Charles Godfrey, the director, and it's my enormous pleasure to welcome Dave Tilman to give the talk this afternoon. Dave is one of the most famous population biologists on Earth. He's Regents Professor at the University of Minnesota and also has a position at the Bren School in the University of California at Santa Barbara. Dave has been lauded with numerous awards. The National Medal of Science awarded in the White House earlier this year, and more parochially, he's a foreign member of the Royal Society. Dave gave a talk in geography in Yavinder's group yesterday about biology, and he won't be talking about his ecological work, but let me just mention a little bit about what Dave has done, which has been truly impressive. One of the classic issues in ecology is how multiple species exist. The simplest theories suggest that they don't exist. And Dave, over 40 years now, has done the most wonderful series of both theoretical studies. He's produced 2 monographs, 2 famous Princeton monographs, and has initiated and carried on one of the largest ecological experiments anywhere on Earth. And this is the famous Cedar Creek ecosystem science in Minnesota, in which he's manipulated prairie communities to try and understand exactly the underlying processes allowing plants to compete. But something that has ramifications and interest for all of ecology. And sort of based on this, he's also become interested in the relationship between biodiversity and ecosystem services. Do we get something special from biodiverse communities? And Dave's foundational work in this area has shown that biodiversity communities can be both more productive and also more resilient to stress. And if this wasn't enough, then in the last few years, well, last decade or so, he's written extensively on land use, on food, and on the topic that you see in front of you. So Dave, come and give your talk. We're much looking forward to it.
Thank you. Well, thank you all for coming. It's a pleasure to be here. I wish I could give my yesterday talk and this talk today, but you'd all be asleep or very hungry by the time I was done. I became interested in food because agriculture and agricultural land clearing is the single greatest known threat to biological diversity. But it's very hard becoming interested in food without also realizing how central that is to the quality of life for 8 billion people on Earth, and how the compromises we all have to make when there are 8,000 of us trying to live our lives on a planet that did not get any larger when it went from 100 million people, 10, 20,000 years ago to what we are right now. And I'm going to talk about a part of this in particular. Let me get here we go, here's the right button. That must have been backwards. Thank you for coming. I'll try this button. There we go. I got it. So, I mean, clearly, we are major users of food, feeding 8 billion people. Not all of them, but a good proportion of them. And we use an awful lot of energy in our modern lifestyle. And these things, as you know, have lots of impacts. I'm going to talk a little bit about those impacts, but really focus most on the food issue. And this is something that I've seen happen during the last 20 or so years. There's been a continual increase, and I would say a totally illogical continual increase in the amount of global food that is being used for non-food purposes. This has just been going and going despite numerous scholarly papers that have been written by many, many people, including me and my students and so on. It just keeps going. I want to sort of show you some of that. So our first work on this, a postdoc of mine, Jason Hill, who's now a full professor, matured very well, wrote a paper that has been very widely cited. It was the first really rigorous full life cycle analysis of the U.S. Proposal at that time to turn corn and soybeans into corn ethanol as a transport fuel to be mixed with gasoline, and soybeans to make biodiesel. And so we did a very thorough analysis. First, we asked the question, when you make a biofuel from corn, are you actually gaining any real energy? Clearly, at the end, you have energy, gallons of ethanol. And it turns out, when you look at all of the sources of energy input into making fertilizer and pesticides and driving tractors, harvesting the corn, fermenting the corn, distilling the corn, getting the ethanol, you get about 10% more energy than you would have had if you hadn't bothered to do it at all. So it's not a very big return on investment. For soybean oil, you get about a 40% return, which is an improvement, if you will, over that. When we wrote our paper on this, we noted, I'll quote here on the bottom, neither biofuel of those two can replace much petroleum without impacting food supplies. Because clearly, corn was being grown then and soybean were grown then to be part of the human food chain. Corn is eaten directly in a variety of products and is fed to lots of livestock and so on, so that it had a major use in the food chain. Even if you put the whole U.S. corn crop and the whole U.S. soybean crop into production of biofuels, it would only meet 12% of demand for gasoline and 6% of demand for biodiesel. So it's really going to be a small game. I thought with that paper, no one would ever bother to do biofuels. I mean, it's a tiny little benefit at a pretty big cost. And we'll talk more about these costs here in a second. Greenhouse gas impacts of biofuels, we did a bunch of analysis. This is the most recent one I've seen. They all come to the same conclusion. Compared to gasoline, the arrow there, the sort of in red, was showing its greenhouse gas emissions per megajoule of energy. What you see is the original estimate for what biofuels might be, slightly less than that, to what we now know they are, is about 24% more greenhouse gases. So the United States, which turns 40% of its maize production, its corn production, into ethanol for cars, is greatly increasing greenhouse gas emission from transport in the United States because of doing that. When our work on this came out, not this paper, but our earlier work I'd mentioned and some other papers, I was invited to speak to the U.S. Senate, the U.S. House. I went to the State Department and gave a talk that then they briefed the president about these ideas and so on. And I wasn't the only one. Other scientists like Tim Scherstringer were there. Others who know this area very well were asked to come in. But the end result was the votes were always in favor of doing something which made money for industry and made money for farmers, even though all the people voting for it had been well informed about the harm it was doing to the environment and other harm I'll talk about also in a minute. And sort of the politics of science are interesting. After doing this work, the head of the American Corn Growers Association went to my university president and suggested that maybe I shouldn't be employed there anymore. He declined granting that. And they came back later and said, maybe I shouldn't be allowed to do research anymore. He declined that. He called me up both times and said, whatever you're doing, do more of it. A good president. But that's sort of the soybean growers did the same thing. And they actually quit giving money to the people who bred soybeans in the building right next to mine as a way to punish the university for having me going around saying these horrible things, the truth. That's just a little bit of the politics that go on in this. So, although it was clear that we couldn't find any way to make a biofuel that was actually out of a food crop that was actually beneficial, we were starting to think about biofuels, and we had been doing research which was already mentioned, that on the effect of diversity, plant diversity on productivity and ecosystem functioning. And we'd seen that when we restored high diversity native grasslands, tall grass prairie, on very degraded soils that had been farmed and abandoned because they no longer were commercially viable, that those soils with high diversity plants on them stored lots of carbon year after year after year. And if you were to mow that biomass, take the hay, and then use it to make a biofuel, that hay has a signature, and that is created because of how much carbon is being stored in the soil year after year, about 3.3 tons per hectare of CO2 being taken out of the air and stored as organic matter in the soil, that you can actually make a biofuel from this that has a very unique feature. It's carbon negative. By growing the biofuel and then burning it, you actually have less CO2 in the air than you had before you bothered to grow that biofuel. That's because we're getting 3.3 tons per hectare of CO2 taken up by the plant and stored as long-lived organic matter in the soil. And that experiment is still running, and the rate of storage just keeps going up. We're getting more and more every year. It's about the same rate every year of carbon stored in the soil. So you can make biofuels that actually work, but unfortunately, no one actually does this yet. It's not really being done. There is one use of biomass from high diversity prairie that was inspired by our work. It was done by a Native American tribe that wanted to restore prairie, and they mow the prairie for hay, they pelletize it, and they burn it to create electricity and heat, which they use on some of their buildings. So it actually is being used. I've actually done at the bottom here, yes, no, no. That is the only use I know of for the idea, but it's a great use, and it is possible to make a liquid biofuel out of this biomass in a variety of different ways, and if they were done, they would have actually a big environmental benefit. It wouldn't be a lot. It's a bit like the corn issue. All the corn only gives you 12% of the energy we need from a liquid fuel. It might be enough to help, let's say, jet fuel, jets and so on, but it wouldn't be a lot because we don't have that much unused land on Earth to do this on. So I guess my first point is 20 years ago, we had really good, solid scientific consensus information on the problems with biofuels, and yet biofuels made from food crops are becoming more and more and more common all around the world. I'll show you data on that in a minute. And we have good ideas about how we can make viable, meaningful biofuels, and we are not doing that. In both cases, it's being done because of the commercial interest of the parties involved. Now, in making a biofuel, if we were to grow a crop for biofuel use, there's sort of a few ways that it is a real problem. One way is to grow more of a crop than we were already producing. We'll have to clear land for it. And when you clear land, there's a lot of carbon in the biomass and the trees, the vegetation, and in the soil in any undisturbed ecosystem that then gets released as you clear the land and comes out as greenhouse gases and makes it very hard to have a viable biofuel. And also, the whole process of converting biomass into a biofuel can take some energy, and you have to be careful that you don't actually make a biofuel the problem. So there's been a push in tropical areas of the world to make biofuels from crops. And the dilemma is when they clear land, they release a lot of carbon. So for instance, in a tropical rainforest, there's about 170 tons of the element carbon in living biomass per hectare of land. And when that land is cleared, that carbon pretty quickly becomes CO2 in the atmosphere. So it's a massive release. And when you farm soils, about 40% of the organic carbon in the soil in the first 50 years of cultivation is lost as CO2 to the atmosphere. So another major release. And if you go to savannas, it's about 30 tons per hectare that is released. And so it's pretty hard to make a biofuel there and not have a problem. And we looked at this and we wrote a paper. Joe Fargione, a student of mine at the time, was the lead author on it. That came out in Science. When we said that basically almost any way you make a food-based biofuel will have a carbon debt. There'll be an immense amount of carbon released when you make the biofuel. And we asked how long would it take for the fuels produced on that to pay off that debt and actually end up having an actual benefit for society. So if we're growing palm oil in a tropical habitat, and it's a very high yielding crop, we calculate it was 86 years on normal upland soils in Malaysia and Indonesia before the biofuel made out of palm oil actually was better than just burning gasoline or diesel. And if you grew it on a peatland soil, it was 423 years before you break even on the biofuel. Soybean biodiesel grown in Brazil in what had been a rainforest, 319 years. Grown in a woodland or grassland, around 30 or so years. Sugarcane ethanol is the only one that almost makes sense. It's only 17 years for when you clear the land until finally you have a greenhouse gas net benefit from the ethanol you make off the sugarcane. So the U.S. approach to biofuels, which is to take food, a commodity crop like corn or soybeans, and turn them into biofuels, became law in 2006, and the law has been modified and extended, including laws that say things like, in determining the greenhouse gas benefit of a biofuel, you cannot consider greenhouse gases emitted when land is cleared to grow the biofuel. Those are illegal to be included in the numbers. Otherwise, the numbers aren't very good, right? It's a strange way to do it. But there's a whole other cost. We're taking food, a crop that had been sold around the world. We exported lots of corn, lots of soybean from the United States to other countries, and we're turning it into something which people don't eat. So we're affecting the human food supply. And there have been a variety of analyses, this is the most recent one, that have asked, well, how much did the price of major cereal commodities, wheat and rice, but also soybeans, go up in response to the U.S. Law that demanded that 10% of all gasoline, in fact, be ethanol made from corn, and some similar things for biodiesel. And analyses suggest that this caused, on average, from what was going on for corn prices before to after this, about a 30% increase in global corn prices. Crops like corn are marketed all around the world, and there's a slight difference in price. Companies make a profit by buying them where it's slightly cheaper and shipping them to a place where it's more expensive. So there's really one price that you pay globally for corn or wheat or soybeans. And these prices have consistently averaged about 20% higher for wheat and soy and 30% higher for corn. And of course, the United States cleared land they wouldn't have cleared, and other places around the world cleared land they wouldn't have cleared, and so on. And now here's the problem. The poorer people of the world have cereal crops as their major source of calories and their major source of protein. So this is the proportion of cereal crops that are brought into a country that are directly consumed by humans versus being fed to livestock or used for some other purpose. And it's on a log scale on the bottom for the average per capita GDP of various nations. You can see that there's this band across there of relatively poor nations and some richer nations where cereal crops are a very major part of their diet. And this part of their diet has become more expensive because of what is happening to biofuels in the United States. Each dot here is a country, and it shows the percent of consumers' expenditure for food out of the total income that a consumer has in countries. I don't have the names of this graph. I just sort of showed you what happened if you push that whole graph up by 25%, by saying prices went up 25%. And the point is, there are many people in poor countries who spend 30%, 40%, up to 60% of their total income just on food. Now, these are real people who also have to have a place to live. They have to rent someplace. They probably need something, clothing for their children, medicine for somebody, whatever it might be. The poorer people of the world are the ones who are massively affected by any change in food prices. And there were many changes and many problems that popped up because of the U.S. use of corn and ethanol, as well as other countries around the world making some biofuels out of their food crops. So for instance, the finance minister of India said in around 2008, when there were riots reported in many countries around the world that were called food riots because people were rioting because they could no longer afford to buy the food their family needed, said, when millions of people are going hungry, it's a crime against humanity that food should be diverted to biofuels. I fully agree. The food riots in the United States, we heard much about food riots in Mexico City. The typical worker on a basic beginning job in Mexico City has about half of their income spent every week on food. The cost of tortillas doubled when the price of corn more than doubled. Tortillas are sort of their bread, if you will, the common food that they eat. They don't tend to make their own, they buy them pre-made. And when you have to spend all your money or more than you have on just food, you really can't afford to live there. And so there were riots, and the government then went in and tried to lower the price by various ways to try to make it less expensive. But the true market cost, because of what the United States had done, it's all supply and demand. Increase demand, don't change the supply, the price goes up. And there were problems there. This happened, food security and instability during the Arab Spring. It's an article that I have a little asterisk here to tell you where you can find it. It was an analysis of what happened during the Arab Spring. I was called by the NATO general who was in charge of African security as this was happening, who said, is this caused by corn ethanol? I said, well, I'm not an economist. Here's what the economists I know have said. Here's my statement on how much food we've diverted and what's happened to prices. I think that is a big cause of it. We caused governments to fail in ways which at that time we were hoping they were going to become democracies. It turns out it's really hard to have a country that has a rebellion end up landing as a democracy. It just doesn't seem to happen very often. So people all around the world, the poorer people, lower income people, were suffering from that. The little thing here, Time magazine, it used to be people read weekly magazines with news in them. I mean, that was before people only looked at their phone to read. And Time magazine was one of the big ones in the United States. And when our paper came out on the carbon debt from biofuels, which I mentioned a few minutes earlier, and a guy named Tim Sershinger's paper came out at the same time. In fact, we sent them in, both of the editors, said we should publish these together. Normally, you get rejected by journals like Science, and we were happy they actually accepted them. And Time magazine picked up on this and had their issue titled The Clean Energy Myth, pointing out that all these assertions by people that this is a better biofuel, this is better for the environment, were lies. The consumers were being fed lies by basically the individuals profiting off these biofuels. So there are increasing periods of food insecurity caused by the massive amount of crops that are now being dedicated to biofuels. But that's sort of where we're coming to where we are today. Here is what the FAO, the Food and Agriculture Organization of the UN, says about the current status of diets and how people are impacted by them. 733 million people have chronic hunger. I mean, I try to lose a few pounds. I know what even my little bit of hunger feels like. I can't imagine what it's like when you can't afford every day, day after day, every day to get even the basic 2,000 or so kilocalories you need. 2.3 billion people have food insecurity, where there are times, not every day, but regular times where they're unable to provide the food they need for themselves and their family. And 2.8 billion people cannot afford a healthy diet. The cheapest things to buy are normally grains, cereals, but cereals aren't a complete diet. You need fruits, vegetables, and so on to actually have a complete diet, so they're unhealthy diets. And this is sort of where we stand. And with this on one side, and the United States and other countries now dedicating so much of their food to biofuels, to feed cars, basically, we are having a growing problem of food insecurity and hunger around the world. On the child side, 150 million children around the world are stunted. That means they're unusually short for their age. It's all because of a bad diet. 43 million are wasting. That means they're unusually thin for their age. 12 million children are severely wasting. And many of the people of these kids with malnutrition, about half of all the childhood death for kids under 5 happens because the children are malnourished. And so it's the increased price of food really hits the poorest people of the earth the most. It's not noticed by richer people. We don't spend much of our money on food. But the poorest people of the earth really suffer disproportionately because of this, in all other ways also, unwise use of foods to make biofuels. So here are some of the really poor countries in the world. And this is the proportion that the typical member of one of these countries spends of their income on food. 40%, 50%, 60, 56% is the highest of these. That's a lot of money to go on food. It's very hard for somebody to have at all of a life, if you will, with anything else, clothing for their kids, medicines for their children, etc., when they have to spend such a high proportion of their income on food. Here are dots for various countries. I mentioned Mexico City. Do I have a pointer on here? No, I guess not. Well, I have a pointer right here. I was born with one. Where's Mexico? Mexico right there. 25% of average income in that country is spent on food. Well, not everyone is average in the country. The poorest people spend half of their income on food. And you could look at other points on there. But the point is that diverting food, which is so central to the quality of life for all 8 billion people on Earth, into some other use, has some very serious impacts. In the United States, the typical wealthy person spends, let's see, the typical 20% lowest income people in the United States spend 36% of their income on food. That's 5 times, about 7%, that the typical 20% wealthiest people spend on food. And I couldn't find data like this for the really low-income countries, but it's got to be the same. A country has a certain average per capita income, but many people are below and many above. And the ones who are below are the ones who suffer massively whenever there's any slight change in food price. Well, why not feed airplanes too? I mean, really, they're hungry, right? Think about airplanes. Those poor airplanes are sitting out in the tarmac and nobody has some delicious corn-based or soybean-based food to feed them. So these are called sustainable aviation fuels. And it's a big hot topic. Everybody wants to make sustainable aviation fuels. There's an organization that pushes this, and I just copied one of their little ads. Airlines should have sustainable aviation fuels because it lowers your environmental impact. Corporations should jump onto the bandwagon, etc. But here's how we actually make sustainable aviation fuel. Soybean oil, canola oil. Or we use alcohol. We turn alcohol made from corn or sugar into basically broken down hydrocarbons, and then we rebuild a fuel that ends up being like the diesel-like fuel that is jet fuel. So there are ways you can make reasonable, truly sustainable aviation fuel. You can't get very much because you have to have something you can use that can be produced as an energy source. It's not like we make a fuel, we make a new energy. We take something with energy in it, we change its chemical form, losing some of the energy, but have a product that we can now put into a jet. Well, there's not a lot of free energy out there in nature that we can take. So we have a problem that way. But it's another use, a growing use. It's sort of the hot new thing like biofuels for vehicles were 20 years ago. If we wanted to make a sustainable aviation fuel out of just corn, it would only take 6.1 times more corn than the whole world produces. If we wanted them out of soybean oil, it would only take 4.2 times more soybeans than the whole world produces. It's just not a practical way to do it, and yet that's how we're going. And as in biofuels for vehicles, where the assertion made in 2006 was, well, within 5 years, we'll be able to turn grass mowed at the side of a road into gasoline, and so we'll only do ethanol out of corn for a short time just to get this industry running. It never turns a corner, never has yet. It seems like making a biofuel out of anything other than a food crop is always 5 years away, and it's been 5 years away for the last 25 years that I know of. So, here are the kilocalories of crops year by year from 1990 till now that have been dedicated to making transport biofuels. 1.3 times how many zeros are there, kilocalories? Well, here's how many kilocalories we tend to need to live for a year. So it takes about 2,000 to 2,200 kilocalories per person to be sufficient to meet their caloric needs. There are 365 days in a year. That gives about 800,000 kilocalories. But it's very hard not to have some waste occur, either when the crop is harvested, stored, processed, or when it comes into somebody's home. So about the least it takes is right around 1 million kilocalories. So think about this. A typical person needs to have about 1 million kilocalories per year. You divide that 1.3 blah, 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 a number across there. I don't even know what to call it. It must have some name, but I don't know what it is. I never got that big a number when I was in school. Divide by a million, and here's what you get. 1.2 billion people. We right now are feeding mainly automobiles, food crops that would provide all the caloric need for 1.2 billion people. There only are 733 million people on Earth who are malnourished for lack of sufficient kcal, and they're probably only missing 200 or 300 kcal a day, not 1,200 kcal, not 2,200 kcal a day. So we have a problem that we're not, if you will, we're not really feeding the world. Now, we don't really ever really try to feed the world. Food is a commercial commodity. We all know that. We get money, we buy food. The dilemma with that is that when we start diverting food, causing its price to go up, we cause an immense amount of harm for the poorest people on Earth. Here's how much land. There are now 80 million hectares of land dedicated to growing biofuel crops. And this has been growing at a rate of 11.5% per year for the last 20 years. So this is not a one-time story. It's a story that keeps going and going and going. Oh, look at this. There's a company called Cargill, and I consider it a very good company. It's located in Minneapolis, where I spend much of my time. It's family-owned. I know members of the family that owns it, and they're wonderful people. And they built a $400 million factory in Iowa that turns corn into fibers and corn into plastics. And so we're turning food not just into biofuel, we're turning it into objects, if you will, physical objects, plastics, clothing, and so on. In fact, this is being sold as sustainable clothing. It's called sustainable because it's made from a renewable crop, corn. And you could easily buy this, I've seen the ads for this. Here are some of these items being sold on the web right now as what had been made from a food crop into a fiber for clothing. And they're described as being wonderful, soft fabrics that are environmentally friendly, live with the earth, be part of Mother Nature. I'm sorry for my sarcasm, but and here's some of the claimed benefits. This is one of the ads for this. I just sort of highlighted it. Corn-based fabrics, sustainable, reduced dependence on petroleum, lower carbon footprint, biodegradable. They perform well. They are lightweight, breathable, moisture-wicking, stretched without the use of spandex or lycra, because in fact, they make the same exact chemical that would have made spandex or lycra by breaking down corn and reassembling it into those fibers. So a life cycle analysis on this, which came out a couple years ago, basically said that all these ads were wrong, that a full life cycle analysis showed that, in fact, these fibers have a greater environmental impact than using petroleum to make synthetic fibers. There was no benefit. In fact, they're more harmful than the thing that they claimed they are better than. So that says the same thing. So I don't think we're ever going to have some global-wide system in which food is treated as a human right, which I think morally I would find that an acceptable idea, a wonderful idea. I don't think it will ever happen. I think we're going to always have an economic system where food is priced by supply and demand, and people who don't have enough money won't probably get as much as they need. But what we are doing right now, by diverting so much food, so many kcals of crops, is we are making food much more expensive than it would otherwise be. And because of that, we have people who are now hungry who would not have been hungry if it were not for biofuels. And in the future, people would not be hungry except for biofuels, aviation fuels, sustainable aviation fuels, fabrics, and plastics being made out of crops. I find that morally reprehensible and actually illogical. So the other aspect I want to quickly talk about is other harms from agriculture. There are many of them, and I really started looking at agriculture because of these harms, because I really deeply believe that we have to find a way that we can provide affordable food for all of humanity and keep the earth a livable place. And agriculture is unavoidably going to play a big role in that. So the various ways that we are harming the future livability of Earth, clearly climate change is one of them. And fossil energy makes up about 65% of all the greenhouse gases that are emitted. But there have been a variety of papers, one of them led by Mike Clark, who was here, that showed that even if when that paper was written, all fossil energy use had stopped, that agricultural greenhouse gas emissions themselves would push the Earth past the 2 degrees C that the Paris Accord said was as far as we should let global climate change. Species extinction. Land clearing is the greatest single cause of species extinction on Earth. And land is mainly cleared for crops. Next is cleared to harvest forests, which often then become grasslands and pastures, and maybe after the stumps have rotted, croplands. And agriculture itself is also a major source of water pollution, nutrients and pesticides, and air pollution that are other problems from it. So we have to find ways to overcome those problems also. Here's the Mike Clark paper on global food system emissions could preclude achieving the 1.5 or 2 degree climate targets. Came out in Science in the year 2020. This just, maybe this says the same thing, and I probably won't bother to explain this graph, but it shows emissions and at what point the emissions are expected to happen between now and the end of the century exceed the boundary that leads to a 1.5 degree warming or 2 degrees C warming. And that boundary keeps going lower and lower and lower because there's more and more greenhouse gas emitted from burning fossil fuels, so it takes less agricultural emissions to push us past the 2 degrees C. And right now, we'll be past that well before the end of this century, the rest of the century. So biodiversity, I mentioned agricultural land clearing is a big threat to biodiversity. A lot of land is being cleared, especially in the tropics. The tropics have some of the fastest growth in human population sizes, but they also have even faster growth in incomes. And the increase in income is the biggest cause of increased demand for products, including demand, let's say, for meats, which require lots of grain crop to produce animal meat in an animal facility. And so the tropics, which are also the home to the world's greatest storehouse of biological diversity, are facing great threats from land clearing and therefore extinction risks. So we did a variety of analyses in a paper that came out in Nature looking at past changes in extinction risk country by country, how the country had changed in income, population, how much land was cleared for agriculture, and so on, and how these factors interacted with each other. And from that, you can forecast what might be happening in the future. And here's sort of where we're going. This is, to me, is a really scary story. And I really first became interested in agriculture because of its impact on diversity and the knowledge I'd gained about how critical biological diversity is for the functioning of Earth's ecosystems. Right now, the lower bars that aren't included in red are where we stand right now. So for South Asia, India, and China, that is the highest bar for large mammals. That means they are the most threatened there of any place on Earth. About 80% of all the large mammals in that region, basically tropical Asia, are threatened with extinction based upon analyses done by the International Union for the Conservation of Nature. And the smaller ones aren't as threatened. The red bar above that shows the projected change in the extinction risks caused by the basically increase in human population, increase in income, and mediated through increase in need for land to produce crops. And what you can see is that Africa, which currently has the least threatened large mammals, which is why people still love to go there and see them in their native habitat, by the year 2060 is predicted to have even greater risk than you see happening right now in tropical Asia. So the forecast of future land change, land clearing, is rather a scary forecast. How much land would be needed should the whole world, as it becomes richer, live lives like most of us live right now? That really is what's happening. The rest of the world wants to live like we live. And if that doesn't frighten you, it should. We should live like they're living if we really want to look at what's going on. Okay, now all of this has an underlying theme that I probably should have articulated sooner, but I want to do it now. We do many, many things now on Earth, even though there are 8 billion of us with high incomes, so we have massive impacts. We do things without actually caring about or understanding what the impacts are. We do things which impose costs. We turn food into biofuel, imposes costs on poor people who can't afford to buy food. It decreases the quality of life for people with middle income who have to spend more of their money on food and less on other things. But we're not looking at that. We're not looking at the total impact of what we are doing. We need to take a look at the world where we ask, what are all the costs, measured in many, many different ways, what are all the benefits of alternative policies? How can we find a way for humans to have wonderful lives, lives I would hope in 100 years and 1,000 years that are much better than ours are right now, but still have a planet that is livable for all people on Earth, that has a livable climate, that has a biodiversity keeping ecosystems functioning, and so on. So this is a little paper in the direction of trying to do what I would call full cost accounting for the future of the Earth. It's a paper done by a former student, not of mine, but of a colleague of mine, and I've collaborated with him. This looks at just maize production, corn production in the Corn Belt of the United States. And if you look at how corn is produced, it's the most heavily fertilized crop in the United States. It takes lots of nitrogen fertilizer. When you apply nitrogen fertilizer, some of that evaporates into the air as ammonia, which is a charged particle. That then attracts in fine dust around it, creating little tiny particles, 2.5 microns in size. It's called PM, particulate matter 2.5 and smaller. They're so small that when you breathe them in, they go into your lungs, into your bloodstream, into your heart, in your body. They're a major cause of heart disease and lung diseases in people. And you can look at people living downwind from maize farms in the United States and what their exposures are, and we have all this modeling we've done in conjunction with the US EPA, looking at typical airflow, release of fertilizer, et cetera. And the annual health cost in the United States for people whose health is harmed by and therefore have to have medical care to treat it is $25 billion a year from the production of corn. Corn farmers make a profit of $5 billion a year. So society is losing $20 billion a year by growing corn. The corn farmers don't know they're doing this. They never do this on purpose, but they have to fertilize to get a yield. So we asked, what could a corn farmer do to try that would actually give a better net benefit to society? Well, the first thing is changing the kind of fertilizer they use. They mainly apply fertilizers by broadcasting them on top of the soil. And they often apply something called ammonium nitrate. And ammonium nitrate, the ammonia dissolves in the air and is the major cause of the PM 2.5 particles that harm human health. If instead you broadcast it on the soil and then plowed the soil so it went into the soil, you get rid of the majority of that emissions. But that would require one more trip across the field. You can also apply, and this is really contra to what it might sound initially, you can actually apply anhydrous ammonia. Ammonia, pure ammonia. Ammonia is the bad thing. But when you apply anhydrous ammonia, you have a tractor that digs a ditch down about 18 inches or so in the soil. It has a pipe that's down there, and it covers that pipe up, and the pipe is about 20 feet long. So they're 20 feet behind the tractor, a foot and a half under the soil, the anhydrous ammonia is being injected, and it doesn't leak through the soil. Soils have in them molecules that are charged in a way that grab onto the ammonia, and it stays in the soil. It doesn't come to the surface. And that anhydrous ammonia is actually a little bit cheaper than ammonium nitrate as a fertilizer, so it saves some money, but you have to have the right equipment to do it. But in the US, all it would take is a law saying you must do this, and farmers would have to do it, but we don't actually ever make laws that tell farmers what to do. So instead, we have a $25 billion health bill, and farmers making $5 billion profit. And you can go down that to the point where in addition to adding the fertilizer properly, you actually add the right amount and not too much fertilizer. And that saves money and gives the farmer more profit. And finally, there are farmers who grow crops on land that have such low yields, they're really not very economic, except they get paid money by the government to do it. And if we got rid of those lands, you move over to the final point over here, where farmers who are still in business are making more money by using less fertilizer and by having less crop being produced and making the price a bit higher. Now, that price a bit higher is a problem we already talked about, right? So trade-offs are what you're looking at. But this is a first little attempt at trying to look at more of the costs of agriculture. And we really need to be looking at all the things we do in this kind of a lens. Excuse me here. It's not vodka. Maybe it is. We really need to do a full cost accounting with 8 billion people heading toward 10 or so billion people, we really have to look at what we're doing, what its impacts are, all of the impacts. It's going to take a lot of thought, a lot of work, and a lot of persuasion to get people to understand this, that we are going toward better lives. But on the agricultural side, we have to look at the health costs, not just the food benefit. And health costs come from how a crop is grown, but also what crop somebody decides they're going to eat and what food they're going to eat. We have to look at all the environmental health, environmental costs and benefits. Farmers aren't going to do something unless they can make a living. They have to make a profit. Agribusiness have to make a profit. And we have to do this in a way which actually makes food be more affordable for the poorer people on Earth. We're never going to just hand out food for free, but we can, by having wise agricultural policies, have foods that are more affordable. And with that, I'd love to hear your questions. Thank you. Oh, here we are.
Dave, that was really sobering. Fabulous.
Sorry. I'm afraid 8 billion people is a pretty sobering situation for the Earth.
So let me ask the first question. Mm-hmm. Then you talked a little bit about the politics in the States. And so at the moment you have an administration that's inveighing against anything that's green, talking about the ridiculousness of wind turbines and things. And of course much of the...
But not golf courses.
Sorry?
Never mind. Sarcasm on my part.
But clearly the biofuel and biodiesel, a lot of it was predicated on green. So how... I'm guessing nothing good is going to come out of it, but how's the politics evolving in the States at the moment?
Well, there are many members of Congress who actually are trying to do things, and they're in both parties, trying to do things that they think are wise for society, who have not been backing some of the more unusual policies of our current president. And so I guess I have some hope. I also hope that every 4 years we have a refreshing event called an election, and things may change in the future. I mean, it's a 250-year experiment. I'd love to go another 250, democracy in the United States. But right now is a pretty frustrating time. It's been frustrating the last 20-some years when it comes to having people take a broad look at where we're going and what it actually means and implies. There are too many people with short-term vested interests who that sort of get in the way of a more logical approach. And I'm not sure how one overcomes that. I mean, there are the people who the 2.3 million people, 2.3 billion people, I mean, who don't get secure food supply aren't voting in the United States and complaining. And yet we impact that. I've often said that everyone in the world who is impacted by another country should be able to vote in that country's election and get a proportionate vote depending upon the magnitude of the impact. In which case, the United States should have a lot of people all around the world voting in our elections because we have a big impact. And right now they don't have a voice which they deserve in a true democracy.
Excellent. Just to remind people that we are broadcast, so bear that in mind when you ask a question. Who would like to ask a question? Ooh, a whole load of them. One there.
Oh, wow. If you were in charge, would you have a blanket ban on biofuels, and would you end government subsidies for growing corn in, like, bad land in the U.S.?
Yes, absolutely. That's probably why I've never been in government.
Right at the back.
Thank you. Hi. So you kind of, you've brought your research to like kind of the highest echelons of the American government, and you've like shown them all this evidence, and you've kind of been shut down probably by corporate interests who have way more sway than you. My question is, do you think that maybe, given that, it's maybe worth not focusing on the global north, but focusing on the global south for kind of implementing the right changes to kind of address this food security problem? And if so, like, what things can people in global south countries or like global south governments do to kind of address food concerns related to the biofuel crisis?
Right. Well, that's a really good question. Clearly, the global south have the more rapidly growing population and more rapidly growing incomes on average, as a percent rate of percent growth in their incomes. And they right now tend to have some of the lowest yields, the least amount of food produced per hectare of land, much lower than that land could give with better agronomic practices. And in the richer countries, we often over-apply our fertilizer and other inputs, apply them at rates higher than we really need to, higher than actually often maximizes profit, because farmers don't really know what is best for them. The main people who talk to farmers about fertilizer are fertilizer salespeople, right? And the people who talk to farmers about seed are seed salespeople, et cetera. And so they get sort of a somewhat biased information. I would be delighted if global South countries can make transition toward higher yielding but wiser and more sustainable approaches. There's been lots of good work done, mainly in China, it turns out, showing how knowledge of a crop, how it grows in a given region, what the soils are, can let a farmer know the right amount of fertilizer to add for that crop in ways where you actually get more food from a piece of land using less fertilizer. So it's much more efficient. And all the fertilizer that ends up in the crop doesn't end up in the water supply, the atmosphere, and so on. So it causes a lot less pollution, as well as saving money and so on. So I'm hoping there'll be a good transition there. And I don't think we're going to lead that transition. I wish we were. I wish the richer countries of the world would chip in the money it takes to help that transition occur, but I don't think that's ever going to happen.
Thank you. Let's go right to the front.
Do you think that there's a sort of commercial case for agricultural waste-based biofuels? And if there is, what do you think are the barriers to its implementation? Why are we still using actually edible parts of corn or soybean?
Right, so that's a good question. When we harvest a crop, we keep the seed and everything else is basically just put back on the soil. Often it's chopped up a bit and plowed in the soil. Sometimes it's left on the top as a weed barrier and to keep moisture in the soil and so on. If we were to remove anything that we remove from that is going to decrease the input of organic carbon back into the soil. So it is plausible that that cost is worth the benefit of the biofuel that is made from it, even though the soil will be becoming less and less rich in organic matter through time. And I've not seen good, clear analyses on that trade-off, but there is that trade-off. I would think there may be some crops in some situations, like in some parts of the world, the straw from wheat or from rice is burned in place. Instead of burning it in place, packing it up and taking it to a place you could at least burn it to make electricity or make a liquid fuel from it. If there's a process that does it, would be a lot wiser thing to do with it. But again, all these things are trade-offs. My big story with 8 billion people, every decision we make is a trade-off. There's no perfect path that doesn't have a cost.
Dave, let me ask you a few things that are coming online. What do you think of intercrops used for energy, and particularly pointing to biogas in France? And another question on biogas, have you studied production of biogas as opposed to liquid biofuels? And then might you also comment on biofuel byproducts, so-called distiller's grain, to be fed to livestock? Is that incorporated in your analyses? Wow,
good questions. On intercropping, one of my PhD students is doing her thesis on intercropping, and we went to, I've been collaborating with people in China Agricultural University for the last 15 years on intercropping. It's just one more way to have diversity. And we know in a normal ecosystem that greater diversity of plants leads to greater productivity, greater year-to-year reliability of production of biomass to more fertile soils and so on. And so the same ideas might well apply to intercropping. And so we are doing work on that. It looks like now, if you choose crops that are ecologically different from each other, you maximize the benefit of intercropping. And that benefit is around 25 to 30% greater total yield of the two crops per unit land than you get by growing each of them in monoculture. So there are some benefits. The hard part is that the optimal approach is to have about a 5-foot wide crop, let's say of maize, and then 5 feet of soybeans, or maybe 5 feet of wheat next to it, and another 5 feet. Nobody right now makes a tool that will harvest just the wheat and ignore the maize, or just the maize and ignore the wheat, etc. So without the right machinery, farmers aren't going to do it. And in richer countries, in the United States, a single farmer can totally farm 500 hectares of maize all by themselves with equipment that's 100 or so feet wide. And we don't have the equipment to do it. We're hoping that as more of the intercropping research is done in other countries around the world, and it gets more well known by agronomists in different parts of the world, that there will be pressure on companies to be the first one to come in and make the intercropping, harvesting, and planting equipment, so you can be leading this charge. Because 30% more yield or 25% more yield is a huge benefit for a farmer. Farmers have fixed costs they have to make with their yield before they break even. So they have to pay off all their fertilizer, the land costs, the seed costs, their time, whatever, just to break even with the yield. Any yield beyond that is profit for them. And so if when they have current yields, 5% of the money they get is actually profit, and you get 20% or 25% more, you now have 30 or so % profit coming off of your field, not just 5%. So the added yield could be a huge benefit, as well as a huge benefit for the world, because more food on the same amount of land means less land will be cleared. It also reduces the price of crops by having higher supply, which if farmers can get higher yields, they can still make a living doing it, and it's better for the poor people of the world with a lower priced crop. That's just one of the questions. What were the other ones?
Biogas
I've never done any work on biogas.
and byproducts used for livestock feed.
Well, byproducts is very common when making biofuels to have byproducts that aren't starches that turn into sugars for, let's say, for corn, be made into an animal feed. So all the analyses I've discussed about the life cycle costs and benefits of ethanol from corn have already taken into account the food byproduct that is fed to livestock from it, and what the cost would be economically, or what the cost would be on land to have grown that product on its own to feed it to the livestock. And so people who do life cycle analyses are really detail oriented. They look at every single little thing. When we first did ours, we asked, well, how much food does the farmer eat? How much energy do they use heating their house? What about their car? We wanted to know if this person is dedicating their life to making a biofuel, what their life living does for energy and food and so on is relevant to that whole equation. So, anyway.
Gideon.
You made a really convincing case. Forgot about the microphone, sorry. You made a really convincing case that we shouldn't be diverting food crops into fuel. Mm-hmm. But of course, we also grow crops for fibre, cotton and other crops, and forestry products which we use for building material and sometimes for wood. They don't compete for food, but they do compete for land, which is possibly the ultimate constraint, and sometimes fertile land. I'd just be interested to hear your thoughts about how much of that we should stop doing if food supply is the critical constraint.
I haven't looked at those crops in detail to give you a really quantitative answer. I mean, we do, wood is a good building material. I mean, it has the downside is it burns, whereas masonry doesn't burn. And in some parts of the world, houses have to be masonry. In the United States, their houses are put up fast, and they have wood frames and often wood siding and so on. The amount of land set aside for forestry is land that no longer is very diverse. Most forest crops are monocultures. And so it bothers me to some extent that we are using so much land to grow a monoculture tree crop. Cotton I guess cotton and wool are two major biologically produced fibers for clothing. I don't have a sense as to how big these things are compared to the whole agriculture enterprise to give you a wise answer. I'm sorry.
Question there.
Hello, thanks for your talk. I wanted to ask you a question more from the energy side of the equation with biofuels. You showed a graph very clearly showing increasing demand in the last 30 years for biofuels. Do you think there's any chance that the demand for biofuels might decrease? And I'm thinking particularly here of the falling cost of renewable electricity in the world and the shift towards electrification of transport and other services.
I would be delighted. I think in the long term it would. I own an electric car, and it's wonderful in terms of how inexpensive it is per mile driven. and how wonderful it is in terms of the lack of repairs. No oil changes. There's so many things that just don't go wrong in an electric car. So I hope that electric vehicles can replace many of the fueled vehicles around the world in the next 20 or so years, and that would get rid of a lot of that demand, which would be very good. It would then help the rest of the global food supply on existing lands quite a bit.
Thank you. Question there.
Thank you. I was just wondering if you could elaborate a little bit more on the kind of policy side, and because obviously that seems to be quite an important issue. You touched on the US, obviously. I personally know a bit more about Germany, where biofuels is heavily subsidized. The use of biofuels is heavily subsidized. With, if universities use it, for example, as their energy source, they basically get it for free. So there's a lot of perception that biofuels is the future, which it seems like it isn't. So I was just curious how your thoughts on how to make that change, because you're correctly talking about the sort of total cost of things. My parents grew up with the idea that you have to really think about people that are hungry in the world. Millennials like we grow up with the idea that climate change is bad. So we need to bring that together maybe as a total estimation. So yeah, I'd be very curious how to make that switch.
Yeah, I think there are many well-meaning people who sincerely believe that biofuels, as they are right now, are beneficial. There's a simple logic. The plant takes the carbon dioxide out of the air to make itself, and then we burn the plant, whatever, some part of it, and that carbon dioxide goes back in the air. And those are the kind of statements that the USDA and the U.S. Energy Department were making early on, like in the early 2010, 2015, so on, in the early days of biofuels. And more analyses that look more deeply at what the whole process is show that wasn't in fact the case. I once had lunch with a high-ranking person in the German Green Party who was convinced that if it was natural, it was good. And there's no way that biofuels could cause any environmental harm that would be worse than petroleum. I'm hoping I successfully communicated the correct answer to that discussion, but I'm not sure I did. So that, I mean, there's so many beliefs that that seem rational and make sense given the knowledge base an individual has. And I imagine many farmers growing corn, I sincerely believe that their corn becoming ethanol is better for the world. And these are things that scientists discovered not that long ago, and it takes a long time between something a scientist knows for the whole world to know it. I mean, normally it has to go into textbooks and be taught to somebody in the 5th grade or 8th grade or 10th grade or whatever it might be before it becomes common knowledge. And so common knowledge doesn't happen as quickly as we are changing the world.
Chap in the blue.
Thanks. I wonder if you've done any similar comparisons with solar panels in competition with farmland, because you could argue a lot of these problems apply to all renewables which have low energy density, and we're currently building a lot of solar panels on good farmland.
Yeah, maybe you are here, and in the United States, most solar panels tend to go up in desert areas, and there the biggest concern is the desert tortoise might be harmed by them. Or they go up on rooftops. I've reviewed a few articles on the issue of solar panels and farmland, and there are some uses of farmland where solar panels don't seem to be like grazing and putting enough light gets through, the grass grows, and you can graze about as many sheep or cattle or whatever it might be on those situations. So there are at least some special cases where that seems to be a viable mix. If it really prevented any kind of food production on the land, then you'd have to ask, what is the benefit versus that cost? And I've not seen it. The things I've seen proposed were ones where they tried to have a hybrid perspective where they could still do some food production and get some energy.
Thank you. Question in the front.
In a net zero world, how are we going to fuel aviation, or do we not have aviation?
That's a good question. I think Aviation fuels to me are one of the more interesting aspects because I agree with you. We're unlikely to have a high enough energy density thing that we can put in an airplane and fly very far. And when I'm in an airplane, I actually want to get to where I'm going and not have to not get all the way there. That's an unpleasant thought. So there are some ways it can be done. The normal way is to gasify biomass and then use what's called the Fischer-Tropsch process, where you can use a metal catalyst to reassemble carbon monoxide and hydrogen gas, which are called syngas, into a liquid fuel and use that as the way to make aviation fuel. That's how some of the scoundrels of the world did it. That's how Germany made fuels in World War II. It's how South Africa had to make them when they were banned from importing oil. And it could be not just a technology of scoundrels, but of good nations in the future. And that could have in it things like a slash from forest operations. It might be better to take that slash and instead of burning it to make electricity, maybe it's better to use that to make aviation fuels, because we can make electricity many other ways than just by burning a plant biomass.
Excellent. Any final question? In that case, Dave, thank you. It's been a super talk, a sobering talk, but really interesting to hear research over many years.
It's sobering talk. Is there wine afterwards or not then?
Thanks very much, Dave. I'm going to wait for dinner.